So finish the rest of that task 4.6. The calendar is posted on the Google Classroom, so you'll know which questions to do. You're doing, I think, the rest of those for 4.6. In 4.7, the task on page 36, now they're having a school project. So Carlos and Clarita had to make a model of a Ferris wheel, like a mini Ferris wheel. This time the radius had to be 1 meter. The center is of the Ferris wheel is at ground level, so that does mean that the Ferris wheel would actually be underground half of the time. So they're making a model saying, let's bring the Ferris wheel down to the ground with the axle at the ground, and it's only a 1 meter radius, so it's a simplified version. They've been making timing it by putting a little doll in a cart and going around. They give us one fact, that this Ferris wheel makes one rotation in 360 seconds. So as opposed to 20 seconds, it's 360. So question 1, use this information. How many degrees does a Ferris wheel rotate per second? Well, if it's going to rotate 360 degrees, and it's going to take 360 seconds to do that rotation, that's going to be 1 degree per second. So that's what it's going to be doing. How high will the doll be 10 seconds after passing position D? Well, it was on the ground, so once again, our height, because the axle is on the ground, it's going to be 0 plus some additional amount because it's rotated 10 seconds. Okay, so the question is, how high would that doll be after 10 seconds after passing position D? So notice in the diagram, position D is here. Ferris wheel is going counterclockwise. If it were to go 10 seconds, you can think of this as, all right, we got a right triangle, we got to figure this value out. After 10 seconds, it's only gone 10 degrees, so this would be a 10-degree angle. The radius of this Ferris wheel is 1, so you want to find this little additional height piece right there. So that little additional height piece you could calculate by saying, all right, it's the sine of 10 degrees equals h over 1, or that additional height piece is the sine of 10 degrees. So that's all we're really adding, is the sine of 10 degrees to this, because that's how high that value would be. And the sine of 10 degrees is around 0.17, so it's going to be 0 plus 0.17. So the doll is not very high off the ground. That kind of makes sense with the 10 seconds, because a full circle is 360 seconds, so 10 seconds is not very high off the ground, and is on the ground when it started, so it's not going to be very far up. If it were to be at its highest height, it would only be 1 meter. I mislabeled that. It's actually meters, not feet. So it's only going to be barely off the ground after 10 seconds. On page 37, they want us to calculate the height of the doll at the different times. Notice that last calculation for 10 seconds was very simple, only because the doll is starting at 0 feet above the ground, and because the radius is 1 instead of 25, we're just taking the sine of that angle, which is the sine of, in this case, 10 times 1 is a 10-degree angle, because it was 10 seconds and it was 1 degree per second. And that's going to be the height. So they want us to go through and fill out this chart. So it's going to be 0 plus, for 20 seconds of rotation, the sine of 20 degrees. At 30, it's going to be 0 plus the sine of 30 degrees. At 45, it's going to be 0 plus the sine of 45 degrees. At 60, it's going to be 0 plus the sine of 60 degrees. And at 90, it's going to be 0 plus the sine of 90 degrees, because that is all that is involved in the calculation of that additional height from that axle, which is really just the height above the ground. So here are the values for the height of that doll. Remember, this is just from 10 to 90 seconds. And because it was 360 seconds for a full circle, this is just a quarter turn, which is the first quadrant. So notice the doll goes from barely off the ground at 10 seconds, and at 90 seconds the doll is 1 meter all the way which is a quarter turn, which makes sense because that was the radius of that Ferris wheel. Question 4 says examine your calculations for the first 90 seconds during this angle of rotation. Can you write a formula for the height? I'm going to say we certainly can. So the height of that dial is going to be 0 plus the sine of that angle, and there's no reason to keep on adding 0 because that doesn't give any value. So really the height of the dial for this most simple Ferris wheel is simply because the radius is 1 and the axle is on the ground, so there's no vertical shift to that Ferris wheel. It's simply the sine of the time because it was the most simplest one. So for the rest of this task 4.7, you've got to go through and answer questions 5 through 8, and then we're skipping ahead as per the calendar, and after 5 through 8 go ahead and do 16 and 17, and there's some 2 practice problems. Don't forget the Khan Academy work for that. So the last questions you're going to do is actually some trig equations like this. We'll talk about that when we do our Google Meet session on Tuesday. I'm in my kitchen right now, so I think I may need to make some tortillas. I definitely don't have any sand, so that's not an ingredient. Otherwise, that's what I'm going to do with my day, and hopefully have some yogurt and granola later. Look forward to hearing from all of you, and see you soon.